Hello everyone, welcome back to the course again. In this course, we'll be discussing about the AR model, which is auto-regressive model. So far, we have discussed about naive forecasting model, moving average, then we discussed exponential smoothing. Now, next comes the AR model, which is auto-regressive model. It is uh, a part of one of the very famous model, ARIMA model. The AR in the ARIMA is auto-regressive model. So in this uh, lecture we will be discussing about the AR model, what's the statistics and science behind it. So let us start with the formal definition. What is an autoregressive model? So as per the definition, an autoregressive model is basically a method used to model future or current behavior in time series. So this is very important. It is for a time series model. What is a time series model? Any data which is indexed with reference to time, days, or time is a reference, indexing reference for that data. Using data from past behaviors in the same time series, the process is basically linear regression. So it is based on linear regression of the variable performance in the current time series against the past performance of one or more variable in the same series. So here we try to correlate with the same time series or the past data. Generally, an AR model assumes that the current series of events can be explained using the past or previous observation results. It uses past outcomes to forecast the value of the next time step or the series. Okay, that's the formal definition. Now, where it is used, what is the application? So, it is used for market analysis, the investments for in the market shares, the funds which are going up and down. So for those calculation, it is used. Then weather forecasting. Obviously, in supply chain, we use for inventory planning or this forecasting. Now, a quick example so that you get a hack of it, uh, how it is working. So, suppose currently is 2 p.m. and we would like to make a forecast for a value at 3 p.m. So, in order to do so, we might use the data which is available at 2 p.m. and 1 p.m. So mathematically, if you want to put it, so for any point time t, the output at any point time t, or if the data we want to predict at any point time t is equal to an intercept, a constant, plus the data at t minus 1 and the data at t minus 2. You can extend this equation or extrapolate this equation till t minus 3, t minus 4 and t minus n. the, the t is the time that we wish to make the forecast. So this t is the time which we want to forecast, and we are relating it with a data point which is one time period behind. So this is also called the first lag, and this is 2 period behind, t minus 2. So in this example we were predicting for 3, so t minus 1 becomes 2 and t minus 2 becomes 1 p.m. Since we are predicting for 3 p.m., 3 p.m. if you want to predict, it will be dependent upon the data point at 2 p.m. and 1 p.m. You can also extrapolate this, just extend it for the time period of like 12 p.m. then going one more period behind 11 p.m., 10 p.m. like that. So what is the limitation? Limitation is, for this we need to have a good p-value. So what is p-value? That we'll be discussing in the next lesson. But yeah, to correlate, to have a good correlation, the p-values for these these variables x t minus 1 6 t minus 2 should be less than 0.5. Okay, so that was the basics about AR model and the definitions, uh, the example and where it is used. And in the next lesson we'll be discussing how in Excel you can build a AR model from the scratch. Thank you and have a nice day.